Myself Manjunath PC, Assistant Professor, Department of CSC Reva ITM. I will be handling you in this session the concept of the arrays, strings and functions. Fine. So, here in this session we will be knowing at the end of this session we will be learning what are basically the arrays, declaring of an array, initializing of an array and referring to individual elements of an array, and also we will see some of the very simple programs on arrays. So, before we start with the concept of arrays, so we should know as a prerequisite what we studied in the previous sessions. So, initially you have studied the concepts of data types provided by the C programming language. For example, you studied what an int is, float is, char, double, or it could be like a short int or a long double, so long int and so on. Also, you studied the concepts of operators and expressions. So, under various operators you studied, so for the arithmetic operators, logical operators, relational operators, bitwise operators, conditional operators and so on. Also studied using of these operators in the expressions also. So, also you studied the concept of looping constructs. So, C programming language provides three kinds of looping constructs: the for construct, while construct and the do while constructs. Of course, the similarities do exist in all the three, for, while and do while. Based on the way it works, we have to use in our programming language. Sometimes in programming we may need to have a logical collection of values of same type in programming. So, logical collection of values means it is all of a similar type of data we may need to store in a program and process certain operations on that. Say for example, we have a list of marks of a student we may need to program on, or we may need to program on the employees of an organization, or we may need to compute the daily temperature in an year, or it could be a matrices and so on. We can notice here, like if you see the list of marks of a student, so all the marks could be of type an integer or it could be of type float. And if you see the list of employees of an organization, so all the names will be of a sequence of characters which we may learn that we call that as a string. And if you look at the list of daily temperature in a year, so all the temperatures we read in the form of a float only. So, all these are homogeneous collections of data. So, all because all these are of a similar data. So, and even in the matrices also in the end of these sessions, so this particular module we will see what exactly the matrices are. So, how exactly we store similar data there and how we are going to perform various operations on that. So, once we have this similar type of data, so we need to perform various operations on that. Say for example, searching for a particular element. Say if you have a list of particular a temperature in an year, you may need to know a particular temperature which all the days it was there. And also, like if you have the list of marks of a student, you may need to search for the marks which is got a maximum marks. So, or sometimes you may need to look for the minimum marks and so on. So, various searching operations we perform on the collection of similar data elements. Similarly, we may need to perform something like the ordering of the elements. So, ordering of the elements means if I have the list of some n integer elements. So, when I have the n integer elements, I may need to arrange the elements in increasing order, or it could be in decreasing order. Or even if we consider the marks of a student which are all of type float, I may need to arrange those particular marks in the increasing order. It could be a float type or it could be of type integer. And also certain operations which we will be performing on these particular similar data elements, or like finding a maximum element, minimum element, an average element, or a mean, which we need to compute on this particular list of elements. With respect to searching, I may need to find the particular value in a given array of elements. So, in future sessions we will see the two concepts on searching, like linear search and also like binary search. Now, consider one particular simple program which you can frame making use of the basic concepts what you have studied so far, that is data types and the looping constructs and simple arithmetic and logical expressions. Now, so here if you look at this particular program, so here what we are trying to do is we are trying to find an average temperature in a week. So here the first declaration, if you see, we need to declare the 7 different types of the floating point types. So this particular statement, so temp 1, temp 2, temp 3, temp 4, temp 5, temp 6 and temp 7, so records the 7 different temperature values in a day, and we need to compute here the average temperature in a week. So we need to read all the 7 temperatures in various days. So we may need to have a printf statement like enter a D1 temperature. Then we read the scanf statement. I hope you know the syntax of the printf and the scanf. So here printf, within double quotes we write what all the messages to be displayed on the screen, and here in scanf we write the type of format specifier which data we are going to read. The temp1 is of type of float, and hence we have used here the format specifier %f. So using this we will be reading the value of temp1. Similarly, we read the day 2 temperature. So with the printf statement enter day 2 temperature, and then we read the scanf %f and temp2. So we will be reading the temp2, so that is the value of the second day temperature also, and so on till the 7th day of a week. So we will be reading all the 7 days temperature. So the dot 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 really doesn't mean that the program works just like that. We may need to type there, so printf enter day 3 temperature, scanf %of ampersand temp3, and then we have to go for printf enter day 4 temperature, and then scanf %of ampersand temp4, and so on up to printf enter day 7 temperature, and then we read the 7th day temperature. So after doing that, so we may need so here, so this particular block we will be using here, you can notice that 7 printf statements to declare that we will be reading the 7 day temperatures, and also the 7 scanf statements. All these particular the statements 7 times we may need to use here, and we have declared here the 7 different variables of type the float. And to compute the average, so we may need to, so first we have to calculate the sum of all this temperature, and since we have reading the 7 different values, we have to divide it by 7. So here we can notice that within this particular so parenthesized expression, we will be computing the sum of temp 1, temp 2, temp 3 and up to temp 7. So here also you can note that the dot 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 doesn't mean, so it just like it works. We have to mention there the temp 3, temp 4, temp 5, temp 6, temp 7, and we have to divide the complete summation by the value 7. So here, since the temp 1, temp 2 all are of type of float, I no need to mention this as 7.0. The 7 itself will so satisfy the requirement, because the lower width the data 7 will be automatically converted into an integer type, and then so the integer type 7 will be automatically converted into a floating point type, and the division will happen in floating, and the result will be stored in the average temp. So just make a note here, I have declared this as an average, so this has to be like an average. Its average is equal to, so this particular value divided by 7, and here we can write like average temperature of a week equal to %f, and then we will be printing the average temperature there. Now let us look at the another program. Let us look at the another program to find average temperature of a month. So it is similar to the previous program. The only change here what we can notice here is, in a week when you are computing the average temperature, we were using only 7 declarations, and then 7 printf and the 7 scanf statements, and in taking the sum of all these particular values, we were taking the 7 independent values there, temp 1, temp 2 up to 7. But when the question is to program to find the average temperature of a month, so we need to declare here the 30 different variables here, right? So we can note that, so here we will be using the 30 different particular variables here. So that is the float temp 1, temp 2 up to 30. So that is we have 30 different so variables of type of float, and here also I will be declaring a variable called average to hold the average temperature, and then we have to use here the printf statement to take the to display the enter day 1 temperature, and then we have to read the day 1 particular temperature with the and temp1. The syntax remains the same here, right? So then enter day 2 temperature, and then we have to read the day 2 temperature with a scanf statement, and this dot 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 says that it will continue up to enter day 30 temperature. We will be reading so the all the 30 days the temperature of a month. So here we have to notice that the 30 times we will be using the printf statement, and 30 times we will be using the scanf statement as well. And finally, so we have to make an equation wherein temp1 will be added, temp2 will be added, temp3 will be added up to temp30. All the 30 different values will be added, and the summation is divided by 30 to get the average. So it will be stored in the average variable, and then we will be printing the average temperature of a month. So finally, with this particular average value. So here we are using 30 different declarations, 30 different the printf statements, and 30 different scanf statement. So in a similar way, if you look at the next program, so this is to find an average temperature of an year. So earlier we computed with the 7-day average temperature, and now it is with the 30-day average temperature, and now it is to compute the average temperature of an year. So here are 365 different days, so we may need to compute here. So the summation of all the 365 different temperatures, and then we have to divide it by the 365. So here you can notice again that, so what will be, so we have 365 different variable declarations, temp1, temp2, temp3 up to temp365. So when it was the week case, it was possible quite that we can declare the 7 variables, and even in the case of month, it was still possible somehow, so that we can declare a 30 different variable. But this is very tedious to declare a 365 different variables of type of float, and then so we have to do like the float average. We have to declare another variable to hold the average temperature in an year. So then we have to use here printf enter day 1 temperature. We have to read the day 1 temperature, and then we have a printf statement to read the day 2 temperature, and similarly we have the scanf statement to read the day 2 temperature, and so on. Here also the dot 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 really doesn't mean that the program just like that works. So here we have to use 365 different printf statements, and similarly the 365 different scanf statements. So is the last printf statement, you can notice that. So here, so I'll be using the enter day 365 temperature. So and then I'll be reading so scanf %f ampersand temp 365. So this way, so 365 different printf, 365 different scanf I'll be using in my program, and then the average is equal to computed as summation of temp1, temp2, temp3 up to temp365. So all these particular values I need to add up, and it has to be divided by 365. So by then I will be getting the average particular the temperature in a given year. So but so here the problem is, so typing this particular 365 floating data types, and then 365 printf statement and 365 different scanf statement is a very tedious task, and this is not the recommended way of programming. So here the one who types this particular program, not sure whether he becomes a programmer or not, so but definitely he may become the typist. So here we should avoid such various declarations in a program. So here the C, so thus we can conclude here is like it is very difficult to program with the too many declarations. So it is recommended that we must use as much as possible less declarations in the programming. So and also it is not recommended way of programming. So this is not recommended to use multiple declarations in the programming. We must use always as much as possible very less number of declarations. So now, so then one more thing with respect to this way of coding is it is not the right way of programming. The reason why it is not the right way of programming is the readability of the programming will deteriorate. The readability of the program deteriorates if I am using too many declarations. Obviously, when I am using the too many declarations, it confuses the reader. So one who is trying to understand the logic of the programming, and even to the programmer also, so this will confuse, and hence we may not program better. So the remedy for this is the C language provides a construct called an arrays. the C language provides a construct called arrays, so which can be used efficiently. Now, so look at this particular code. So to compute the average temperature of an year, so but here I am using an array. So you can see that, so in the previous program where I was using so 365 different declarations and 365 so different printf statements, 365 so different the scanf statement, so and all that. But if you look at this particular code, so here I am using the concept of arrays. Of course, you are very new to the concept of arrays, so you will not be knowing what this particular construct mean. So, but still, so later we will get to know that what exactly this construct. At this point of time, we just need to know how the code will be very simplified with this particular. So here we just need to know that how the things could be very simplified, so by making use of the construct called arrays. So now see here, I have one declaration here, float temp of 365. This statement is avoiding me to declare 365 the different declarations. In the earlier, without using the concept of arrays, I was declaring like the float temp1, temp2, temp3 up to temp 365. So but now I have only one declaration, float temp of 365. So I have an array of 365 data elements which are of type float. Of course, you will be learning soon here, so what exactly these arrays are, how it is to be declared. Now here I need to declare one more variable called an average. Initially it is taken as the value 0, and then so int I, so one variable I am declaring here as of type integer. So then here when I is equal to 0, this is a looping construct. Since you are already aware of the looping constructs, let's see how exactly this particular the code segment will work here. When I is equal to 0 here, so it will come to the looping block. So in this loop or in this block, I am displaying a message, enter day %d temperature I. Since the I value is 0 here, it prints a message as enter day 0 temperature. So day 0 temperature means it is day 1 temperature. So the array index starts from 0, which you will be learning very soon. You will get to know what exactly so it is used and how exactly it can be used in the programming. So next, when I is equal to 1, it will reach for enter day 1 temperature. So basically here the day 1 means day 2 temperature, because we have started from I is equal to 0. And when I is equal to 0, you can note that we will be requesting for enter day 0 temperature. So then here the scanf, so percentage of and temp I. So since the I value is 0, I will be reading temp 0. Temp 0 means nothing but the temp 1 value which we had declared in the previous program. And when I is equal to 1, we will be reading here the print of enter so day 1 temperature here, and we will be reading like scanf percentage of and temp I. So I value becomes 1 there. So here we will be reading scanf percentage of so temp 1 there. So now this particular method I can read the 365 different data elements here. So how many lines hardly I have here? 1, 2, 3, 4, 5. I have just a 5 line code, so which can avoid me typing 365 different printf statements and 365 different scanf statements. So we should appreciate the arrays for this particular support. And then if you look at the computation of the average, so here also what I am trying to do here is, since the average value is initialized to 0, so when I is equal to 0 here, I will come to this loop. And here since I am using only one statement in a loop, it is not mandated that I should use here the opening and closing curly braces in this particular case. And even if I use here, so it works in the similar way. Now average is equal to average plus the temp of I. When I is equal to 0 here, I will be taking here avg plus temp of 0. So initial value of avg is 0 there, so I will be taking that temp 0 value into average. Again when I is incremented to 1, so again we will check 1 is not less than 1 is less than 365, so it will be coming to the loop, and here again I am computing avg is equal to avg plus a temp 1. So since earlier we have recorded the value of temp 0 in average, and that is getting added to the temp 1. So here the temp 0 and temp 1 is added, and then the result is stored in a avg, right? So this way I will be computing the sum of all the 365 days different temperatures in a sum. So basically here one particular code is supposed to, right? So here it could be like, so finally, so avg equals to AVG, so divide by 365. Basically right now the AVG is holding here, so only the sum of all these particular different temperatures, and here the one statement is supposed to write to compute the average, so that is AVG equal to AVG divided by 365. So that now the AVG will print the average temperature in an year. So we can count here, like, so hardly we have 1 2 3 4 5 6 7 8 9 10 11 12 13 and 14. Hardly some 14-15 line of code you have, but when you look at the previous program, so that is without using the arrays, here we were having 365 different declarations, and again one more declaration called average, and then 365 different printf statements, and then 365 different scanf statements, and then finally we are computing average as temp1 plus temp2 up to temp365 divided by 365. So it was more than, so nearing more than 700 statements you have in this particular code. But if you look at this particular code where I am using the arrays here, this is reduced to hardly to a 14-15 line code. So here with respect to this, we have to appreciate the use of the arrays, so which will reduce the typing involved in programming. Now, so let's see. So now, so let's see what an array is. So just now we have seen that an array temperature what you have declared in the previous slide. So temp 365. So here, so temp is an array of 365 different floating point elements. So thus we can say like it is a logical collection of values of similar types. Sometimes we call this as aggregate data type. So an array is an aggregate data types. So these are sequentially indexed and have a fixed size. So this particular thing, what exactly the meaning of sequentially indexed and have a fixed size, we will see in the next slides. So here the array is a logical collection of values of similar type. We use arrays to hold the similar data types. So it could be like, so the various an array of an integer elements, or a list of marks, or a list of names, or the list of temperature, which we have seen right now. So these are some of the different types of the similar data types what we can use in the programming. Now, so before we go for using an array, so let's see how to declare an array in C programming. So here we can see like, so this is a syntax of using the declaration of an array in the programming. So here we have the data type, so followed by the name of an array, so followed by the size of an array. So here the data type would be like, it can be int, float, char, double, and so on. These are the primitive data types basically. So these are the primitive data types, and sometimes we may use here as part of the data type is considered, we may use even the user defined data types also. There exists another data type called user defined data types, so which you may study in future. So here these are the primitive data types, or these are basic data types. We have int, float, char, double, long double, or all these are the primitive or basic data types. So we have to mention the data types here first, and data type followed by the name of an array, and the name of an array is, it can be any valid identifier. When you use the term identifier is, so this is in C language, an identifier can be like, it must start with a letter or an underscore followed by 0 or more sequences of letter, underscore, or a digit. That's the rule we're supposed to follow in naming any identifier. So identifier is used to identify any programming element, right? So it could be a variable, or it could be name of a function, or it could be name of an array, and so on. So here we can use as part of the array name any name of our own choice, but it should not be a keyword. We have to make sure that the identifier whatever we use here, there should not be a keyword. Then followed by, this is most important here, which has to be kept within the square bracket. This particular bracket what we are using is, this is a square bracket. Okay, so fine. So don't use here the opening and closing parenthesis. Normally this opening and closing parenthesis will be using for functions or to enclose the expressions, but this has to be a opening and closing square brackets. So whenever you are learning the programming language, you must be very sure with the syntactic rules followed by the programming language. So here we will be using the array size. When you are using the array size here, it can be any valid and integer value, so it can never be a floating point. We should not use the floating point value there, so it has to be an integer value there. So then now consider, so this particular declaration int num of 5. So here we can note like, so the first is the data type, then followed by the name of an array, followed by the array size. So here you can see like, so here I will be using the data type as integer, and name of the array I will be using it as the float. Sorry, here the name of the array will be using it as num. Here the data type here it is integer, and the name of the array I am using here as num, and then the size of the array I am declaring it as a 5 here. Fine. So how I can read this particular element now? So num, an array of 5 integer elements stored in a contiguous memory locations. So what exactly the meaning of contiguous memory location is? They are stored in a continuous memory location. So it is not like the normal variable declaration. Say if I am declaring, say something like int x, y and z. If I am declaring the 3 variables of type x, y, z, x can be stored anywhere else, and y can also be stored somewhere else, and z can also be stored somewhere else. They are not arranged sequentially. But here when I use the term array here, they are arranged in a sequential order, in a continuous memory locations. Thus we say like, say an array of 5 integer elements stored in a contiguous memory location is the name what we can define the int num of 5. So int num of 5 is in a continuous, so it's an array of 5 integer elements stored in a contiguous memory location. You see here, so a of 0 is the first element, a of 1 is the second element, a of 2 is the third element, a of 3 is the fourth element, and a of 4 is the fifth element. Since we are starting the index from 0, this we call it as an index, and here the index is 0, here the index is 1, here the index is 2, and here the index is 3, and here the index is 4. Right. So now the addresses correspond to this particular element. Is it here? It is 2460, and here I am calling it as 2462, and here I am calling it as 2464, and here it is 2466, and here it is for 2468. Here I am assuming that here we are using a 16-bit machine. So when I am using the 16-bit machine here, the size of an integer could be 2 bytes. So since it is 2 byte, if the 2460 is the starting address here, then the next location will be like 2461. So this particular thing and this together forms 2 bytes of data, which is a store which is a place for holding the value of a of 0. Similarly 260, so 2 and 263 are the places where the value of a of 1 will be stored. So this is also of 2 bytes, 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 because each integer is taking 2 bytes of memory area here. So that we can note that the element num 0 and num 5, so here, so instead of a it could be like num. So here even if I take here as a, so here it is a of 0, a of 1, a of 2, a of 3, a of 4. So here I am using num here, it could be like num 0, num 1, num 2, num 3 and num 4. So all these particular elements, num 0 is holding the first element stored in an address called 2460, num 1 or a1 what I am calling here, so is stored in a location called 2462, and a of 2 is stored in the location 2464, a of 3 is stored in 2466, and a of 3 is stored in 2466, and a of 4 is stored in 2468. Right. Now, so here we can note like each element is of same type and same size. So that's what we have seen like. So here array 0 so is of 2 bytes, a1 is also of 2 bytes, a of 0 is also of 2 bytes, a of 1 is also of 2 bytes, a of 2 is also of 2 bytes, a of 3 is also of 2 bytes, and a of 4 is also of 2 bytes. So that's what we said. So each element is of same type and same size, and each element can be treated as a normal variable. When I am accessing in the programming each of these elements, they can be treated as independently as a normal variable only. A of 0 is one variable, A of 1 is another variable, A of 2 is another variable, A of 3 is another variable, and even A of 4 is also another variable there. Then array elements hold junk value when uninitialized and declared locally. This is similar to the automatic or the local variables what you use normally. If I declare a variable without any initialization, so locally, or that is within a block, then the default value what it holds, so will be a junk value, or sometimes we may call it as a garbage value. So because whatever with the memory content present there, so that will be displayed over there, and that is irrelevant to our programming, so our program variable. So we call that as a junk value or the garbage value. So here we can also see like the array elements are used to similar to the normal variables. So the functionality how exactly we use the array variables here, this is similar to the, so making use of the normal variables. It is similar. So A of 0, A of 1, these are similar to the normal variables what are declared x, y, z. Only thing is here we are grouping this particular similar data type and we are calling it as the name A. So here it is named as num here, so it could be A there. If it is A, then it is like A of 0, A of 1. If it is num here, then it could be like num of 0, num of 1, num of 2, num of 3, and num of 4. So thus what we can conclude here is an array is a homogeneous collection of elements stored in a continuous memory location. So thus an array is a homogeneous. So the term when I use the homogeneous here, the meaning is we are storing the similar data elements here, right? So all are of type integer, so we call this as homogeneous elements. So in future you also study, so there is a collection of heterogeneous data also in possible in programming, which may call it as the structures. So at this point of time we restrict to the homogeneous collection of elements, and we can see like all these are stored in a continuous memory area. It is not like A of 0 is stored in something like 2460 and A of 1 is stored like in some other address like 3000 and so on. They are in a continuous memory location, right? So this we define it as an array is a homogeneous collection of elements stored in a continuous memory location. Now, so consider the three different declarations here. So int max, int marks of 100, float temperature of 365, char name of 60. So here you can see like the data type what I am using here is int, and the name of the array what I am using here is marks, and the size of the array what I am using here is 100. And with respect to another declaration, we can see like the data type what I am using here is float, name of the array what I am using here is temperature, and the size of the array what I am using here is a 365. And if you look at another declaration, so here the data type what I am using is char here, and name is an array of, so name of the array here, and the 60 is the size of the array. You just look back to the syntax of declaring an array. It must be data type followed by a single space and then array name, at least single space has to be there, then followed by an array name, and within the square bracket I must specify the size of the array. So here with respect to that, so here we can see like marks is an array of 100 integer elements. So that's marks is an array of 100 integer elements stored in a continuous memory location. So it's also called a contiguous memory location or continuous memory locations. Similarly, a temperature, so is an array of 365 floating point elements stored in a contiguous memory location. Similarly, a name is an array of 60 character elements stored in a continuous memory location. These are some of the valid declarations of an array there. Now, if I use the declaration something like int a of 60. So this is wrong. This is not a valid declaration of an array. So here the bracket what I will be using here, it must be a square brackets. It cannot be a parenthesis. Parenthesis is used for enclosing an expression or with respect to the functions. So here this is an invalid declaration. So it must be like the int, so followed by a and then a square bracket, and then we have to specify the size, whatever the size I want. So this is an a is an array of 5 integer elements. Now, so when you have declared the arrays, so let's see how to initialize an array here. So array can be initialized at the time of their declarations. So similarly, we declare we initialize the normal variable at the time of declaration. The same way we can even initialize the arrays at the time of their declarations. Say even normally what we use here is, so when I am using the normal declaration like int x is equal to 5. So at the time of declaration of x, so I will be mentioning here, so what is the value of it. So 5 is the value of x. At the time of declaring what an x is, I am assigning the value to it. So this is, so array can be initialized at the time of their declaration. So here int a of 5 is equal to 14, 20, 167, 25, 85. These are the different values why I am, so what I am assigning to the an array of 5 integer elements. Since the array size is 5 here, I am mentioning here 5 different elements, and we know that the array index starts from 0. So this is the value correspond to a of 0, this is for a of 1, a of 2, a of 3 and a of 4. So pictorially we can see here like the a of 0 value is 14, a of 1 value is 22, a of 2 value is 167, a of 3 value is 25 and a of 4 value is 85. Respectively we can see their addresses also. Here also we can see like, so a is an array of integer elements, so each element will take 2 bytes of memory area. A of 0 is starting at 2460 and 60 and 61, so will be used by this a of 0, and 62, 63 will be used by, so a of 1, 64, 63, 64 and 65, 2464 and 2465, the two addresses will be used by a of 2, and similarly 2466 and 67 will be used by the a of 3 elements, and similarly so 2468 and 469 will be used by a of 4. So when you start from 2460, 2462, 2469, I will be using the memory locations. So here, so we have 10 different bytes of memory location here. So each integer will take 2 bytes. So and here 5 elements I have declared. So 5 to the 10 bytes of memory is allocated for this particular array A. And you can note that A is a name of an array, whereas a of 0, a of 1, a of 2, a of 3, a of 4 are the different elements of an array, right? Now, so array elements can be reassigned, that is a new value can be assigned. So directly sometimes we may need to assign some other values for individual elements. Say here if I do a of 2 is equal to 95 here, we can see that earlier the a of 2 value was 167 and now I am reassigning a value called 95 here. Now we can show that a of 0 is unaltered, a of 1 is also unaltered, whereas a of 2 is overwritten with a new value what it has got. So here the a of 2 value is 95, whereas the earlier value it was a 167, and the a of 3 is untouched and a of 4 is also untouched. Their values remains the same there. Now in continuation with initializing an arrays, so on partial initialization, uninitialized elements will get the value as a 0. So consider this particular declaration here, a of 5. The size of an array is declared here as a 5, whereas the number of elements what I am mentioning here is only 3 here, right? So we say like the index will start from 0. So a of 0 will be 14, a of 1 will be 22, a of 3 will be 25, a of 0 will be 14, a of 1 will be 22, a of 2 will be 25. I have not mentioned any value for so a of 3 and a of 4. So these uninitialized values by default will get the value as a 0. So here we can note it like, so a of 0 is 14, a of 1 is 22, a of 2 is 25, a of 3 is 0 and a of 4 is also 0 here. And you no need to put comma here at the end of the last element. We can notice like every element is separated by a comma, a delimiter which is used to assign the elements to the array elements at the time of their declaration. So even in the previous slide also we can see like, so here we have declared an array of 5 integer elements here. So 14, 22, 167, 25, 85 all are separated by a delimiter comma here, right? So 0th value, first value, second value, third value, fourth value, and the last value no need to be in so delimited with the comma. We enclose this with the flower brackets. So here we use a flower brackets. Don't get confused here. When I am declaring an array, I use here the square bracket to specify the size of an array, and when I am assigning the value at the time of declaration, I will be using here opening and closing flower braces, right. This is not the square bracket, rather this is a flower brace what I will be using here for initializing the array at the time of their declaration. So in case of partially initialized arrays, so a of I is equal to 14, 22, 25 I am assigning, that is a of 0, a of 1, a of 2, and other two elements are not being initialized there, and they get the default value as a 0, right. So array size is optional if it is initialized on declaration. And this is quite interesting here. So here I am not mentioning the size of the array, I am just mentioning the number of elements that could be stored in this particular array. So A is an array of integer elements, and here this is optional one. So I am not mentioning the size. The reason why I am not mentioning the size here is, so the all possible elements that could be stored in this array I am mentioning it here. So 14, 22, 25, 67, 89, 26 and 77. So here how many elements we have is, so 1, 2, 3, 4, 5, 6, 7. Since we have here 7 different elements, the size of the array will be automatically computed as a 7. So in this case the 7 is the size of the array, and here we cannot think that this is an partially initialized array. So here this is a partially initialized array, because here I am mentioning the size as 5 and here mentioning the values only 3. So remaining 2 elements by default will take the value as 0. But in this particular situation, since I am not mentioning the size of the array, I am just mentioning the elements that could be stored in the array. So the array size will be computed as same as the number of element I am specifying during the time of my initialization. So here when I am initializing an array at the time of declaration, the size of the array is optional, right. So here a of 0 is 14, a of 1 is 22, a of 2 is 25, a of 3 is 67, a of 4 is 89, a of 5 is 26, and finally a of 6 is 77. So 0 to 6. So the total number of elements present in this particular array is 7 elements. Now, so initializing arrays. So some of the invalid initialization could be like this particular declaration and initializing. If you see, you can see like the array is declared as a size of 5. So here this is an array of 5 integer elements, but if you look at the number of elements present in the declaration initialization, we have 1, 2, 3, 4, 5, 6, 7. So altogether we have the 7 elements here, but here the space what I am providing is only for the 5 elements. When it is 5 elements, so each element will take 2 bytes and into 5, so altogether the 10 bytes of memory is allocated for the array name A here. So when I am using here 7 elements there, so obviously there is no place for holding the 6th element and the 7th element. So this could be an invalid initialization. So because it is not matching up with the array size as well as the number of elements I am not mentioning here. But if I am not mentioning this array size, then it works fine. The reason is, since I am mentioning the number of elements there, based on that the size of the array will be computed automatically. But when I am mentioning the size of the array here, the number of elements what I should mention here is, it should be less than or equal to the maximum number of size of the array what I am mentioning there. So here it is exceeding that particular value, so which is greater than the 5, the size of the array. So we can say like this is an invalid initialization of the array. Now if I want to initialize array with 0 elements, so we know that when I declare a variable locally, the default value what it will get will be junk value. Say for example, I have a declaration int x. So here I have not initialized any value here. Say for example, I am writing a program int main. This is my declaration, and I have one printf statement. Assume I have included here or #include stdio.h. So, here since I am not initializing any value here, since I am not initializing any value here, so the value that will be printed here in this case, so will be a junk value, will be junk value. So, it is not exceptional to even to the arrays also. So, even if I declare here int a of 5, then here so the elements a of 0 to so a of 4. So, all these elements will hold the junk value because it is not initialized or explicitly any value is assigned to it. Without assigning any value here, I am trying to print here the value of x. So, here I will be getting the junk value. Fine. So, now the question is how to initialize array with the 0 elements. If I want to initialize all the elements with the, so all the elements of an array with the 0 elements, then my statement would be like, if I need to initialize a of 5, all the 5 elements will be junk value. If I want to initialize this with the 0, then I may need to use 1, 2, 3, 4 and 5. Is it necessary that we need to use here the 5 different 0 values? So, it is not mandate. So, just the declaration along with the initialization a of 5 is equal to 0. So, this is sufficient because this is partially initialized. So, here so a of 0 will be taken the value as a 0 and remaining uninitialized elements a of 1, a of 2, a of 3, a of 4 will automatically get the value as a 0. So, not necessary that I should mention there all the 5 different values over there. So, now so you can see like, so the statement for this is like int a of 100 is equal to 0. So, here it is not mandated that, so I should use here 100 zeros. So, to say that the initial value of all these particular elements is a 0. If I declare 1 0 here, that is sufficient. A of 0 will be taken as 0, a of 1 will be 0, a of 2 will be 0, a of 3 will be 0. The uninitialized remaining elements of an array will automatically take the value as a 0 there. Next, note, so while using the arrays, the array index starts at 0, not 1. See here, so always the array index so start from 0 and it does not start from 1. So, so here the always the index will starts from 0. We start saying that so a of 0, a of 1 up to a of n minus 1. Fine. If array is declared as so 5, so then it is, so the index will start from 0 and it goes up to 4. Now, array size cannot be 0. So, it is not recommended, so or it is not possible to declare an array size as a 0. So, when it is array size is 0, so the number of bytes to be located will be 0 there and we cannot store any data over there. So, it is not possible to declare an array with the size as a 0. So, like say for example, if I have a declaration like int a of 0. So, this is an invalid declaration. I am mentioning here 0. So, here at least I should mention that one integer value there. Okay. So, if I am declaring, assume something like this, int a of 1. So, our a is an array of one integer element. This is same as just declaring int a. Fine. So, a is a variable of type int, whereas a is an array of one integer element. So, this is not recommended way of programming. When you have multiple integer values, only at that point of time, so we have to go for the arrays. When you want multiple similar data type elements, then we have to go for the arrays. If I want only single element, then no meaning in going to the arrays. And this is an improper declaration. Though this is valid, this is not the recommended way of using the array. So, when I am using the array, so it should be having multiple similar elements there. Now, here, so we should never access the array elements outside the boundary. So, that is outside the boundary means, so here int num of 15. So, num is declared as an array of 15 integer elements. Since it is declared as a 15 integer elements, so num of 0 to num of 14 are the only valid elements which are to be accessed. Num of 0 is the first element, num of 14 is the last element. Since I am using 0 to 14 altogether, I will be having 15 elements. Here also num 15 is invalid. So, because so we have location only for the 15 elements, num of 15 could be the 16th element. So, which is not not an allowed element here, because here I have declared only 15 elements, space is allocated only for the 15 element. Num of 15 could be the 16th element, which is not stored here. Similarly, num of -1 is also invalid. We should not use even num of -1 also. Now, so let us look into one simple program. So, using an array. So, program to print an array. So, here we can see like, so I am declaring the norm. So, I am defining including here the stdio.h header file, then int main, then I am declaring the array here, and I am initializing the array with a certain set of values here. So, 12, 34, 65, 74. You can note like a of 0 will be 12, a of 1 will be 34, a of 2 will be 65, a of 4 will be 74 there. Next, I am printing the values there, a of 0, 1, 2, 3, 4. So, I am printing all the 4 values there. So, 0 to 4, 1, 2, 3, 4. I am printing only the 4 value here, and a of 4 is taken as a 0 there. Since it is partially initialized, so that will be taken as a 0 there. So, a of 0, a of 1, a of 2, a of 3, and here this method of printing an array is not easy and not recommended if array size is large. So, here it is like I am using 5% d, 4%, 1, 2, 3, 4. So, one more percentage is to be added over there. So, 5% d, and each of the elements I am going to print there, a of 0 value, a of 1 value, a of 2 value, a of 3 value, and a of 4 value. When I print all these values, so here it is like it will print 12, 34, 65, 74, and the last element is not mentioned there. So, means by default it will take the value as a 0. So, that will be printed over there. So, but here I am using, so 5% d here. So, what could be the situation if I am using here a of 50? So, then, so 50% d if I am using here, then I am not taking the advantage of using the arrays. So, here, so this is not the recommended way of programming. So is the reason we say like this method of printing an array is not easy and not recommended if array size is large. If it is of 50, 100 or so on, so this may not be the right method of printing the array elements. So, now program to print an array using the loops. We have the looping constructs using which we can print the elements of an array. So, here we can see like, so the same code I am trying to print the array elements using the loop. So, a of 5 equal to 12, 34, 65, 74. A of 0 value is 12 here, a of 1 value is 34, a of 2 value is 65, a of 3 value is 74. This is partially initialized, and obviously the a of 4 value will be 0 over there. I am declaring one local integer variable int I. Now, the array elements are, I am trying to print that using the loop here. So, for I is equal to 0, I less than 5, I plus plus, I will be printing the value %d comma a of 5. See what happens if I is equal to 0. So, when I is equal to 0, 0 is less than 5, come to the loop. Since I have only one looping statement here within a block, I am not using the opening and closing flower brace there. Print of %d a of 0. So, a of 0 value is what? 12 will be printed over there. Immediately I is incremented there, again it will check 1 less than 5, the condition is true, prints the value of a of 1, again it will go for the iteration, the incrementation, it becomes 2, 2 is less than 5, it prints a of 2 value, that is 65 will be printed, further I is incremented, it becomes 3, 3 is less than 5, and then a of 3 value will be printed, that is 65, further I is incremented, it becomes 4, 4 less than 5. So, then it will print the value of a of 4. Since a of 4 value is 0 here, this is not completely initialized here, partially initialized. So, the a of 4, the last element what we get there is a 0 there. So, this will print the values as 12, 34, 65, 74 and 0. So, similarly, we have few more programs. So, array constructs can be used in a simple and easier way using the looping constructs. So, here even if there are 500 elements, then so this array size could be 500 here. Here I can take the condition as I less than 500 and use the same code. If the previous method is used, so then I may need to use here 500 different %d symbols. Then this is same as the becoming a typist rather than a programmer. So, here we should see that we have to make use of the looping construct to make use of the array constructs. The array constructs can be used in a simple and easier way using the looping constructs. Fine. We will continue in the next session. Thank you.